Hello, everyone. Happy Tuesday. I'm going to give everyone just a second from the waiting room to join in here before I announce today's presentation and today's presenter. Think we've got people trickling in just about now. Well, thank you so much for joining today. We've got Jeff from Brava, and today's webinar topic is sustainable resilience, the benefits of synthetic roofing. So a few things I want to know about today's presentation. First of all, happy holidays. Thank you for joining this week. We've got a really great presentation coming up. Second one, this is AIA approved, and I know a lot of you are trying to get those last minute credits. So I want to make sure you receive credit for joining today's presentation. If you weren't able to drop in your AIA number when signing up for today's presentation, the first link I'll drop in the chat is a form to fill all that out to ensure you receive credit for today. Second thing that I want to announce is where to find Brava Tile on Acelab. So I will take over a screen share real quick. Okay. Okay. So if you go over to Acelab's material hubs and type in Brava, it'll be that first one that pops up here once you click on manufacturers. Once you scroll down, you'll see Jeff's contact information. Really great way to get directly in contact with him for any of your project needs. And if we keep going down, lovely products here with some photos as well. So we click on the Spanish barrel tile roofing. There's some really great information on this page. You've got your 3-part specs, you've got your construction details, as well as your CAD files, a way to save these products directly into your projects or your firm library. And then if we scroll down here, there's some more things like their performance data, as well as some other cut sheets and brochures as well. So I think that is absolutely everything before Jeff jumps in. As always, any questions you have, drop them in the Q&A, send me a chat, and we'll get to them at the end of today's presentation. Thank you so much.
Thank you. So thank you for joining us again. I also wanted to note, so we just got reapproved or recertified for GBCI credit. So if you're looking for those, just let me know. Sorry for not having that earlier. So this is Sustainable Resilience, the benefit of synthetic roofing. A little bit about me. My name is Jeff Soukup. I am based in Chicago. I'm the A&D lead for Brava Roof Tile. So I'm currently covering the country. We're adding some people to help support. But if you need anything, please reach out. Brava is a sustainable synthetic roofing manufacturer. We manufacture synthetic slate, shake, and Spanish barrel tile. We do this in Iowa. So I will talk to you about the benefits of synthetic roofing, and I will talk a little bit more about Brava afterwards, but we'll go through the AIA-approved presentation. So again, a kind of housekeeping. So the course description: during the Industrial Revolution, engineers were looking for ways to create better products. So there was shortage on material. They wanted to create longer lasting, better performing materials. So new technologies allowed them to create or advance these materials, leading to longer lasting, better performing, sustainable materials. In this course, we're going to look at some traditional materials, some traditional roofing systems. We're going to look at some synthetic roofing systems. A lot of this, we are going to be talking about exterior building products as a whole, so we're not going to be bogged down in roofing. So for the roofing aficionados, sorry to disappoint, but we will talk about a little bit about everything. Our learning objectives today. So again, just looking at the history of synthetic building materials, how did we, what was really the impetus for the creation of these materials, and then how did we, create these great products? Look at some of the traditional building products that were natural materials that have largely turned to synthetic. Compare and contrast some of the sustainability attributes of synthetic materials over traditional materials, looking at their recyclability, their durability, protection against fire, and then finally looking at synthetic roofing, how it can protect your structures from whether it's rot, pests, or other wind, other problems that we're dealing with frequently. So this light bulb is just a little bit of an example to kind of prime the pump. So looking at innovation, without innovation, where would we be today? This light bulb is an example of, we've gone from the traditional filament or Edison bulb to our new LED bulbs. I can set my current LED bulbs. I can set them using an app on my phone. I can sync them up to my Spotify playlists or my playlists. They're tremendously um, smart or efficient. They cost less. Their life cycle cost is very minimal. They are the norm or the standard. We've actually restricted the ability to manufacture and sell old filament bulbs because these LED products or other current light bulbs are just a better product, and they've come to be through innovation. We've tired of replacing the old bulbs, turned to a more energy efficient product, turned to a more durable product, and we've changed the norm to where they are the standard now. With that kind of thought process or that type of innovation in mind, we're going to look at other exterior building products that have moved or made that transition from natural material to a synthetic counterpart that in many ways is a better performing, lower cost, and more efficient product. This little blurb here, the world inside and outside is evolving and the materials that encase it are quickly following suit. Just a great reminder that we should always keep our ears open or our eyes open, evaluate the newest materials, the latest technologies that are coming on. Are we specifying the best product for this application? I know we're here for a reason. It's to get better. So a little bit about the story of synthetics. So we're going to look at these materials, your exterior building products, so your trim, soffit, fascia, your fenestration, your decks, your siding, and then roofing, our exterior building envelope. Many of these materials, or all of these materials at one time, were majority natural materials. They have, for the most part, transferred over or changed to being a standard synthetic product. So the origins of synthetic materials. So if you kind of look back historically, you get the mid 1800s. We were experiencing rapid population growth. We're creating urgent needs for food, housing, clothing. And to meet these demands, the industries turned to, we expanded production, construction, manufacturing, which placed a significant strain on on many things, but two in particular, labor and natural resources. So to overcome these challenges, we sought for ways to do more with less. This is going to be a reoccurring theme here, doing more with less. So we turned to technology to solve our manufacturing and science for our resource development. This shift led to a real greater efficiency in engineered materials, semi-synthetics, fully synthetics. We started modifying abundant but underutilized resources with either chemical processes or advanced manufacturing processes, and developed some really unique products that not only replicate their natural counterparts, but many times outperform. And because we are manufacturing these materials from readily available products, a lot of the times we're able to produce it faster, we're able to produce more, so we're bringing the cost down for a equivalent or better product. So looking at some of these early advancements or early innovations, inventions, Portland cement is probably one of the most important that we're going to see here. Portland cement was created by Joseph Aspdin in 1824. His father, I believe, was either a quarryman or a mason, and he saw the value of Portland stone. So Portland stone on many of the prolific buildings throughout Europe, especially in England, we see Buckingham Palace, the Tower of London, London Bridge, many others throughout history. Even the UN is made out from Portland stone or partially from Portland stone. But the problem with Portland stone is that it's only quarried on the Isle of Portland in Dorset, England. So geographically restricted. It's difficult in 1824 to get this material anywhere other than kind of London or Western Europe. So Joseph Aston wanted to create a material that looked largely like Portland cement or Portland stone, but more readily accessible. So he ground some limestone, he introduced some clay, some water, and heated it, and ended up creating Portland cement. So one of the most formative kind of engineered advancements in our society. Vulcanized rubber was another great story. So Charles Goodyear was had a contract with the U.S. Postal Service, or whatever is being referred to in 1839. He had a contract to manufacture rubber mail bags. So the mail bags, he was using natural rubber and treating it with nitric acid. And this worked, but when it would rain or it would be hot during the summer, he noticed that the mail bags would begin falling apart. They would get really tacky and disintegrate. So he eventually lost his contract with the Postal Service, but didn't lose his ambition to create a better performing rubber. So he partnered with a guy by the name of Nathaniel Hayward, who was working in New England and treating natural rubber with sulfur. He had kind of the right properties going, but he didn't have the process. So one night, as the old story goes, Charles Goodyear was up late at night tinkering. He had a mixture next to him. He knocked over his mixture of rubber and sulfur onto a stove. The stove, cooked the material or vulcanized, and created this, much better performing material. So he kind of lucked into this step, but really created a rubber that had a higher tensile strength, was resistant to swelling and abrasion, remained elastic over a greater range of temperatures. So vulcanization, obviously, we still see a ton of vulcanized rubber in process today. Not strangely enough, or surprisingly, not part of the Goodyear Tire Company. That was just an homage to Charles Goodyear and his invention, but still big in the world today. Engineered timber, another one that, again, all of these are kind of the Industrial Revolution, either pre, during, or kind of post Gilded Age. The engineered timber market, it traces all the way back to ancient Egypt. There are, history, or there have been sightings of cross-laminated ply in ancient Egyptian excavations. But really, where we see the engineered timber market really grow and innovate was during the mid 1850s. You look, it's the Industrial Revolution. There's tons of growth in throughout the UK. They see that we're harvesting all of our forests for all of the building that we're doing, and there wasn't a ton of lumber left for furniture. So the furniture industry got together and decided to start compressing all of the offall, grinding and compressing all of the offall with a little bit of adhesive and shaping it. So you end up getting your, flat goods were first. They started compressing it into different shapes for furniture, and really, advanced the industry and created the basis for what we know as our sheet goods, our OSB, our CDX. All of these were founded in England during the 1850s. Just a unique picture up here. This one in the upper right hand corner. This is from a fair in New York in the mid 1860s, I believe, where they created an elevated platform or elevated railway using entirely out of plywood. The next, celluloid. So this is the first semi-synthetic plastic. Celluloid was created again in the mid 19th century, post Gilded Age. There, when you were a distinguished family, you always had a billiard table, and at this time we had really decimated the elephant and rhino population throughout Asia and Africa. So, billiard balls require ivory. All of the ivory supply was fairly decimated, so they were looking for substitutes. So again, kind of doing more with less, or running, creating substitutes for things. Um, a billiard ball manufacturer in New York City decided to create a $10,000 contest for anybody who could create a suitable replacement for ivory. And John Wesley Hyatt and his brother created celluloid. So celluloid is a mixture of, I believe, cellulose nitrate and camphor. It is a really great material, holds solid over a great range of temperatures. Can be polished, has a great hardness, and can hold colors very well. This material, they ended up winning the contest. They were never paid, but John Wesley Hyatt went on to form the Albany Dental Plate Company, where he manufactured, among other things, billiard balls, dental implants, combs, piano keys, everything that we really associate uh, with ivory. But they also were very formidable in the injection molding process. So we don't really use celluloid anymore. Celluloid for a very long time was used in the film industry. It was extremely flammable, which is why we don't use a ton of celluloid anymore. If you're familiar with the movie Inglourious Basterds, the theater scene where they burn the theater at the end of the movie, that is what you could expect when you're lighting celluloid. But just a really great product, kind of advanced the industry, and also was very formidable in the injection molding process, which is still, one of the most widely used manufacturing processes for plastic today. Bakelite, the final one that we'll look at. So Bakelite was dubbed the material of thousand uses. Bakelite is the first mass-produced plastic. In the time before 1907, when the electricity or the world was being electrified, the cables used to be insulated with natural shellac. The natural shellac that they used was only sourced by scraping out a hardened resin inside trees that were infested by the East Asian lac bug. So not a very easy replicable process, very labor intensive, expensive. So a lot of scientists started focusing on creating a new insulating product, or a synthetic shellac. And Leo Baekeland and his brother created theirs. This is a mixture, of phenol and formaldehyde and something else, but it was dubbed the material of a thousand uses. So it was found anywhere from appliances to electronics, jewelry, automobiles. It was formable or easily shapeable, moldable. It was a perfect insulator for electric cables. So really the first mass-produced product, a real great achievement. So once we kind of figured this out, it wasn't until World War II that we had this huge proliferation or adoption of synthetic materials throughout the world. And that was largely driven, again, by kind of a perfect storm. So we are importing most of our natural rubber from South America, Africa, Asia. A lot of these areas were cut off due to the war for the Allies, so they had to look for ways to replicate these materials. Through the Wartime Production Act, the U.S. invested a ton of money, ton of people, ton of resources into the creation of synthetics. So they financed about 50 emergency plants. By 1944, those plants were turning out 750,000 tons of synthetic rubber. That would eclipse all of the importing that we had done before the war effort. At the same time, they were creating new materials or perfecting materials like bakelite, creating new materials like plexiglass, creating nylon, replacing a lot of these natural materials with new synthetic materials, and really winning the war or turning the tide of the war by being able to manufacture these new materials. So after the war, we're left with all of this capacity for manufacturing synthetic materials, but we don't really have an output for it or a use for it. And that's where, building materials come. Again, it was kind of a perfect opportunity. You have the baby boom, you have the new developments like Levittown, where these mass produced suburbs. So plastic was a perfect material for construction. Today, building is plastic. The construction industry is the second largest user of plastics, the first being the CPG or consumer product goods. Um, I'd argue that it's the construction industry is a better, steward or user of plastics, by and large. We're using these for long-term material use. We're using them because from top to bottom, they're high performance, durable, and now we're turning the tide where these can be considered sustainable products if they're manufactured correctly, and utilized correctly. So just looking at some of these product categories that have gone from a largely natural material to synthetics, starting with siding. So siding relieves a ton of attention because it protects our buildings from the outside element. It's what we're looking at mostly. Vinyl siding, so it's improved tremendously over the years. It's very durable, it's affordable, has very consistent colors, and can remain virtually maintenance free over its life. Engineered wood siding, if you're moving up, looking at some of the really great engineered sidings available, can mimic the look of natural materials at a fraction of the cost, and even to your composite materials or fiber cement. These are manufactured with durability and longevity in mind. Decks. So gone are the days where we are sanding, staining, sealing every 2 to 3 years. Splinters, can be a thing of the past. These are excellent maintenance-free products. There are some recyclable options these days. There are some more fire-resistant options these days. But if you look at we started in the kind of the early 90s to where we are today with composite decking, it's really unique to see the progression. Vinyl windows, so these rose in popularity during the 70s, and early 80s. Homeowners looking to build more energy efficient solutions for their homes. They're now one of the least expensive window materials. They have some of the longest lifespans, um, much longer than many wood and aluminum options. They can certainly help increase your home's energy efficiency. Low maintenance, come in a variety of colors, styles, very easy to customize. And since their invention, vinyl windows have really become a preferred choice in the industry. Your trim, soffit, and fascia. So wood trim is very vulnerable to rotting, cracking, splintering, termites, pests, and obviously fire is always a concern, especially these days. So the trim industry, fiber cement, PVC, other modern synthetic trims will outlast any wood material and be virtually maintenance free over its life. Won't absorb moisture, deteriorate from weather. It's just a wonderful product. So looking at synthetic materials from your pad all the way up to the roof, they're going to stand up against the elements, increase your energy efficiency, reduce your maintenance, last longer, and hopefully, if you're using a solid synthetic product, look as good or nearly as good as the day they went in. So when we're looking for products to specify for your next building, just consider how the materials are going to impact the environment and durability of your structure. Do the due diligence that you need to, and specify some manufacturers that have gone the extra step and are considering, if they are synthetic, the sustainable options that not only meet the aesthetics that you're looking for, but are innovative and helping push the industry move forward. Frequently, we hear, it's not natural. I want natural. Natural is classic. Classic is valued. It is, the natural materials look beautiful. but over time they are becoming you know heavy, brittle. They make renovations difficult. I love the look of a traditional clay tile, but over time they can degrade. The um, maintenance associated, or maintenance, even the installation is becoming more difficult, finding the skilled artisans to install these materials. I know we're joining from all over the country. Regionally, you can probably find a good slate hanger, but in many areas of the US you cannot. So looking to find a better, different options that can achieve these visuals, not having to over engineer your roof structure to accommodate the weight of these tiles, is something you want to consider. These materials will last forever, or a very long time, but they do, these days they can be difficult to maintain and keep looking beautiful. Cedar shake, or different shake materials have been a big challenge for a lot of people in the recent years, with the continued problem with wildfires, deforestation, and then just getting insured is becoming increasingly difficult. So seeking out products that may replicate this, and be a little bit easier to maintain and install over the course of their life is worth considering when you're specifying material. The costs associated with having these materials is not just with installation. There is a cost to our environmental impact. So um, are we deforesting? Are we mining or quarrying for slate? Most of the slate that we're seeing in the States around here is being imported these days. Thinner profile, not as nice colors, a significant carbon footprint being transported to the U.S. Just a lot of things to consider. If there are materials that are manufactured from recycled existing materials that we can repurpose for roofing, that would be a unique option. So this is where I'm going. A lot of these materials are these synthetic materials are recycled, so it's very counterintuitive to kind of where we are today. We've been told plastic is terrible for the environment, but it can be a bit of a misconception or misconstrued that if a material is existing and we can recycle it, then it's counterintuitive, but we can take a plastic and turn it into a roof, and it can be very sustainable. So just looking at for these opportunities is keeping an open mind. So looking at some of these roofing materials, synthetic roof manufacturing has come a long way. There are some really great, easily reputable, or we can replicate many of the existing looks out there, and you're not going to see the degradation that you would over time. Gen 1 of synthetic roofing had a lot of issues. So if you think about it, you take a black piece of plastic, put it on a roof, and let it bake in the sun, you're going to have some issues, and a lot of lessons were learned over time. The original materials, there are a lot of manufacturers that have come and gone, but the current manufacturing process, the advances that we've made in polymer technology and just manufacturing technology has improved over the last 5 years, and 6 years now. The industry itself has grown 30 to 35%. So real significant adoption. We're still in a very early adoption phase of synthetic roofing, but it's becoming a bigger and bigger category in the roofing industry as every year goes by. Now modern synthetics are considered, high-end, premium products. You can achieve some really beautiful looks with these. So looking at some of the synthetic roofs, what are they made of? So a lot of the times, what are your products made of? Mostly plastic, some rubber. Some manufacturers are using mostly virgin material, where many manufacturers are using recycled content for this. using both types of recycled content, so your post-industrial and post-consumer. One of the biggest challenges that we have as a manufacturer, post-consumer, we still as a nation are not very good at recycling. So post-consumer is it's very difficult to find a reliable, consistent stream. But whether it's post-industrial or post-consumer, we're still diverting material away from the landfill, trying to flatten the curve of embodied carbon. Um, then just looking at I'm getting ahead of myself, but the ability to recycle after a useful life, it's very important. Mineral pigments are big in the industry. So mineral pigments or inorganic pigments are not going to degrade like a synthetic pigment would under UV. So we use mineral pigments like carbon black, red iron oxide, green earth, azurite, your burnt umber, indigo, all of these to really get that very durable or very UV resistant, fade resistant color that you see with natural products. As I was saying, many of these materials are made from recycled materials themselves, but they're also able to be recycled at the end of useful life. So it's not as simple as going down to the local recycling center, but many manufacturers do have recycling programs. You can get that big green bag, take all of your roofing off and send it back to the factory, and it can be turned right back into another roof. So one of the bigger questions that we get are how are these roofs tested and how do they perform? The biggest concern, obviously, fire, plastic burns. We know that. So how will it perform? Um, fire synthetic roofs are tested exactly at the same as any other roof product would be. The UL 790 ASTME 108 tests. So this is three different tests. The burning brand test, which you see here, this essentially we just take a burning satchel, throw it onto the roof structure and see how it burns. Does it go out? Does it continue to spread? Your spread of flame tests and your intermittent flame tests. So these are all meant to mimic real life fire, how a roof would interact with a fire in real life. Um, After these tests are done, the results are aggregated, and then your roofing structure or your roofing material is assigned a classification, Class A being the most effective, Class C being the least effective. So not getting crazy here with the naming or the classifying. Most synthetic manufacturers will receive a Class A or have a Class A option. Many of these manufacturers will have a Class A composition tile and then also a Class A assembly. Impact resistance is a big one these days. So I think in the mid 90s, a bunch of catastrophic storms came through the Midwest and devastated, many roofs out there. The insurance industry wanted to develop a way to evaluate roofing materials. So they came up with the aptly named steel ball test. Essentially, we just drop a steel ball from 20 feet, graduating from 1.25 to 2 inches. You drop the ball twice from 20 feet in the same spot and then evaluate for moisture penetration afterwards. So this will tell you how resilient your roof is to impact. Many of the leading synthetic manufacturers will achieve a Class 4. There's also a bit of a misnomer as far as Class 4 goes, or impact resistance. Impact resistance, when I first joined the industry, I thought it was, impact resistance would be this is going to prevent moisture penetration, but my roof's also going to look, nice afterwards. This doesn't tend to be the case. So a Class 4 impact roof will still dent, like a standing seam, or an asphalt can be a Class 4 and still show a lot of signs of dent. That's part of the benefits of the synthetic roof, is that because these are plastic and they're very resilient, you're not going to notice a lot of damage with this. So Class 4 will also provide you, it'll mitigate any moisture penetration or not allow moisture penetration, and it will also look beautiful afterwards. Wind, so the gold standard here, is going to be your Miami-Dade County NOAA. or notice of approval. Um, all of the synthetic manufacturers, to my knowledge, have these. So you're gonna want to look for manufacturers that have met the standard and can warrant up to 80 mile per hour winds. Many of the synthetic roof tile manufacturers will warrant up to 110 or even 130 with some modified installation techniques. And so this is really about future proofing. So we want to make sure that, we're designing for today, but also designing for, all of the new weather that we're going to experience 10, 20, 50 years from now. Many of the synthetic roofing manufacturers are working to produce cool roof compliant materials. So for your Title 24 California cool roofs or your building and energy efficiency standards, many of the synthetic manufacturers have products that are compliant and meet the solar reflectance required in these areas, but also making sure that we have products that can withstand increasing sizes of hail or greater winds. We want to make sure that we're doing everything we can to design appropriately for today and for years from now. Um, Testing has shown, just to beat you over the head with this, that synthetic roofs are able to endure a ton of impact more than many of the other traditional options that we see out there. Another benefit is, because these synthetic materials won't absorb moisture, they're fairly immune or very immune to the freeze-thaw cycle as well as extreme heat. So in areas where you would typically have to, be very careful with what you're specifying, you're a little bit more insulated or protected with a synthetic roof. So styles, the materials out there these days are, creating some really beautiful products, great products that mimic natural slate with a lot of variegation. Your shake, Spanish barrel tile, you're not only locked into, this isn't just a residential product. It's great for institutional use. So a lot of universities, we have historical buildings. We, don't want to deal with the ongoing maintenance of a natural material. So synthetic is a really great opportunity here, especially with the fantastic ability, sustainability attribute or sustainable attributes that you associate with synthetic roofing. Again, more opportunities for different verticals. So whether it's higher ed, whether it's historical restoration, commercial, multifamily, just great opportunities. And these are going to look, just as good or, very close to what they would look like 20, 40, 50. The biggest knock on plastic is that it doesn't go anywhere. And I think the synthetic roofing industry has done a good job of saying, let's turn that negative into a positive and use it as an advantage. So we are taking, the biggest knock on plastic and using it for roofing as a benefit. For you, the way your work holds up, obviously it's going to be your business card or, your reputation, part of your legacy. So, specifying products that are going to last, 40, 50 years, um, benefits us all. So just looking at some case studies, this is a project in the Florida Keys. The homeowner wanted cedar shake. They were unable to get it due to concerns with wind or storms. They were also worried about corrosive salt weather and how that would impact their cedar shakes. So they ended up, working with a local contractor who told them about synthetic shake, installed it, very happy. They were able to get their impact ratings, get a Class A fire rating, and then have a Florida Building Code approved product. This project, Reisterstown, Maryland. So this homeowner purchased this home, had an asphalt roof on it, wanted to put on a natural slate roof, but didn't have the budget to engineer the roof to support the weight of natural slate. They found a reputable synthetic slate manufacturer and were able to get the color, the look that they wanted without having to re-engineer the roof. Mountain Village, Colorado. So we're seeing this more and more often. This HOA was told that it was time to re-roof. They were told by their insurance company, we are not going to allow you to put on another cedar shake roof. Sure, you can probably find a treated shake that is, will achieve a Class A, but having to reapply the coating frequently, dealing with the coating potentially running off when it would rain. They didn't want to deal with that. So they found a synthetic roof manufacturer that could achieve the Class A fire rating, looked authentic enough to meet their rigid standards, and they ended up finding a great product and being very happy with it. In Grand Prairie, Texas, this homeowners association didn't want to deal with, I believe they had clay tile or concrete tile. They were dealing with fading. They were dealing with issues with slate and wind, and evaluated a synthetic Spanish barrel tile, found that it met their needs, installed it, and they are extremely happy to this day. So just looking at the conclusion of this CEU, just looked at some of the Industrial Revolution. How did they create materials that were stronger, more waterproof, better lasting, better performing? Looked at some of the advances in technology. How did we get here? Looked at traditional materials where they can, have some negative associations with them or challenges with maintenance and durability, or being brittle, or warrant insurability. Then looked at some of the benefits of synthetic roofing. This is similar. Now you'll be able to discuss some of the synthetic achievements, the innovations, look at some of the synthetic roofing systems and compare them with traditional roofing systems, look at sustainability attributes of synthetic materials, and then discuss some of the benefits of synthetic roofing. So that is the CEU portion. If you have any questions, or I'll briefly run through Brava. So Brava is a manufacturer of synthetic roofing, if you didn't know already. We were founded in 2008. We're manufactured in Washington, Iowa, which is about an hour south of Iowa City. Brava we manufacture slate, shake, and Spanish barrel tile. We are soon adding a fourth. We're going to add a flat tile. And we are also bringing on a second plant outside of Atlanta. So in a town called McDonough. So we're trying to keep up with capacity or the demand for our product by adding capacity. But we have been growing significantly for the past 10 years and bursting at the seams in our plant. So it's a great move for us. So Brava is very sustainable. So we will qualify for LEED. Brava is manufactured from mostly post-industrial material, but some post-consumer. We have a big challenge finding a steady stream of post-consumer material, which is why we largely tend to use post-industrial, but still kind of diverting from landfill and making a very sustainable product. We use mineral pigments. So the benefits of mineral pigments, I think they're more realistic. They're, a better, more opaque color. But they also are much more resistant to UV degradation, so making them very fade resistant. The benefits, other manufacturers may use synthetic. Synthetic is, what you would associate with newsprint, different print media. The oldest works of art, the frescoes that we're familiar with, they were all done with mineral pigments. That's why they still last. So we look at mineral pigments as a very important part of our material. Brava is unique. Brava uses a sand casting compression molding manufacturing process. So we take actual products, so your slate, shake, Spanish barrel tile, we sand cast, we create molds, and then we do a compression process. So when we are manufacturing, we take our inputs, so our post-industrial recycled plastic, add mineral pigments to them, create tiny pellets. Then we mix the pellets, melt them down, and extrude them in what I always kind of refer to as like a 380-degree Tootsie Roll, that comes out, it's a big charge and it goes into our molds. When it presses, it creates this variegation that you see in the wood or in these shakes. This is a better example of it. So you're getting unique molds and you're also getting every single tile is going to be unique because of this compression molding process. So I think that adds to the authenticity. The other advantage is you get this really super fine detail. So when you are compressing, plastic or polymers don't want to go into corners or take into small places because we are compression molding and not injection molding. We're able to fill those little nooks or crevices and create these very fine details. Other benefits. So I don't like saying zero maintenance. You're always going to have to, all products are going to have a little bit of maintenance. So if you're up there, you're going to have to blow off your roof if you have a lot of, a lot of leaves, or maybe get up there and wash a spot or two, but largely, way less maintenance than even with a traditional asphalt roof. Wind resistance. So Brava has been tested up to 211 miles an hour without failure. We warranty our high velocity install to over 130, which is your Miami-Dade or Florida Building Code approved. Very resistant to fading because of our use of mineral pigments. Brava also manufactures a high elevation UV resistant formula, which we typically sell in the mountainous west regions. Surprisingly, being at a high elevation because we're that much closer to the sun affects your it increases the speed of fading. So we have a special formulation for that. Brava is a 50-year warranty product. So, it will stand the test of time. I refer to this kind of as a legacy roof. So 50 years for, performance. And then we have a 10-year fade resistance warranty. So our fade resistance warranty, our material will be within 400 units of its original manufacturing color after 10 years. Brava is going to be thicker, lighter weight. So if you can install an asphalt roof on your structure, you can install Brava. Brava is about 300 or 3 pounds per square or 300 pounds per square or per roofing square. So just a lightweight, very durable product. So just looking at some of our different profiles or some of our installations. So just some, again, gorgeous shake looks. This is an arboretum. We do really wonderful with, park services. So, a lot of these services are tired of, replacing shake every 10, 15 years. We're the durability of shake is a little bit not as robust as it was, because we're using a lot of warm grown lumber. So, a lot of the park services and other areas are turning to synthetic. Just some real neat houses. This house is in the Wall Street Journal for, an obscene price tag. But just, some real um, cool projects that we've done. This is one of my favorite details on a roof that I've seen in a long time. Just obviously, in my very biased opinion, I think this is very authentic and natural looking. This is a cool product or project. So not, the most beautiful building, but this is Henricus County in Virginia, or Henricus Historical Park. Building was from somewhere in the 1700s, and we redid the roof, and I think it's a real testament to how authentic Brava looks. These are our different colors. You can do a custom color if you were looking for, but typically we try and keep on the natural cedar color life cycle. We have our Title 24 compliant cool roof colors that are available to you. Coming in 5712, and we also have a solid tile for your ridges, or sorry, your rakes and eaves. Class A, we have a Class A composition tile or Class C. You can achieve a Class A is going to be more expensive. Class A can also be achieved through assembly. So we just want to see a radiant barrier included. Slate, very compelling or authentic look. This is an Armonk. This is a neat project in Delaware, so near and dear to my heart because it's where I'm from. But this house was on the Instagram account, Cheap Old Houses, and somebody redid it using our material. So the reason why I think this is such a great example of our product is the top roof is Brava. The portico down here is the original 1914 slate. So obviously you can tell, but it's complementary in my opinion. Different colors. We have standard 12-inch or multi-width and 6, 9, and 12. We have all your hip ridges, components, starter tiles. And then your Spanish tile. So this is a Spanish mission church in Oklahoma City called Stanley Rother Shrine. It's a pretty unique project. We did a custom color for them. They had original clay tile. It was falling apart. They weren't happy with it. So we made a custom color. The turrets, we couldn't get the Spanish tiles to accommodate the turrets. So we used our slate to do this. And I think it turned out really, really well. This church was hit by like a few tornadoes within weeks of each other 3 years after the install, and they only lost a handful of tiles. So it was again, another testament to the durability and wind performance. Historic train stations, lots of multifamily. So throughout the southeast, southwest, just a great opportunity to specify these materials that are going to last for you. Higher ed. So this is a university down in Florida. Do a lot of work in Florida. And then just some, resort work that we've done. Yeah, so these are the different colors that we have. Lots of variegation in our Spanish tile because we're trying to mimic, the natural variegation of clay. But all of the different accessories, everything that you need for an installation. Our resources are available, excuse me, through Acelab. We have new Revit system families. We have light PBR textures or 3D rendering textures available, new specs, and a comprehensive suite of architectural details for you. This is where we think we are in the adoption curve. So if you think where fiber cement siding or composite decking were in the early 90s, mid 90s, I think that's where we currently are. You're just going to see more and more synthetic roofing coming out because it does have such a great story and why it's a greater upfront investment, but long term, your life cycle cost is way less than replacing your asphalt shingles every 10, 15 years, even though they're supposed to be rated for 25 years, or doing any maintenance with natural cedar, clay tile, concrete tile, slate. So there's a lot. We last portion we do a lot of training, so we offer certified installers, but it's not required. We just want to make sure that the subtle differences required for installation, mostly leaving a 3/16 to 3/8 keyway in between the tiles, are followed. But we are here to see you from project concept to installation and then post. So thank you for your time. I think there are a couple questions. Is that correct? No. All right.
Hi, Jeff. Thanks so much for the presentation. We got just about 5 minutes until we need to wrap everything up. So I'm going to give you a few questions here that came in through the chat
Sure.
Q&A. If you're good with that. Cool. Okay. I'm just going to go in the order they came. So if we don't have time to answer your question, Jeff will reach out to you after today's presentation. The first one, what is added to plastic type of shingles to limit fading, and how effective is this compared to clay tile roof colors?
So Clay, we had color stabilizers, and I would be able to share, I guess, I'd have to reach out to my technical team to get the exact names of the materials. But we had a few color stabilizers and then things like titanium oxide, um, as a filler, which helps us against that. But really, it's the inorganic pigments, the mineral pigments that protect much better against UV or are much more UV resistant than other colorants.
Awesome. Okay. What type of fasteners are recommended for Brava roof materials?
So for our slate and shake, we recommend either ring shank or a stainless steel, roofing nail. We prefer to see, obviously, stainless steel is going to be better. And then for our Spanish tile, I like to see it screwed just because, it does have the undulations or the curves that, deal with a little bit more wind uplift. But ring shank nails are perfect for it. And our standard installation, I think, will give you is rated to 90 miles an hour at a 10-inch exposure.
Awesome. All right, next question here. What fire ratings do your products achieve, and what underlayment is required to achieve a Class A rating?
For a Class A rating, you have two options. We have a Class A composition tile, which can just be applied or installed with a standard underlayment that meets your ASTM standards for I think 22. I'll share that later, but um, just a standard underlayment. If you are doing a Class A assembly, you would install a radiant barrier, either EcoChief Solar Hide or Low E Thermosheet. One of the benefits here is if you are doing work in California and you are required a Title 24 compliant roof or a cool roof color, you can kind of double dip. So you need a Class A roof assembly as well. And your Class A, the radiant barrier that you're using will exempt you from your Title 24 requirement because it has an R value. So it's a great way to double dip and be able to use, get exempted from the Title 24 requirement and be able to use, say, a darker color roof if you're looking for it. I think it's may have been a little confusing, but either assembly or Class A composition.
Perfect. Okay, I think we have time for one or two more here. Do you sell direct or only through distribution? And kind of going hand in hand with that is another question. What are the minimums?
So we sell through distribution and we partner with the largest big three in the US. So QXO, ABC, and SRS roofing distributors. In the Northeast, we go through a two-step distributor, so it's a little bit more regional. There are no minimums. We, have our regular lot, and then if you're going to do a small quantity, there's a little bit different. But one of the benefits is that we are stocked at many locations throughout the US. So, the minimums really don't apply in many cases.
Awesome. Okay, last question I think we'll have time for here. What tolerances exist for dimensional accuracy?
So I don't know if you're which dimensional accuracy or you're like our manufacturing tolerance. Our tiles are going to move. They're going to expand and contract. So when we are installing we require a keyway, a gap between the materials between 3/16 and 3/8. So you're probably looking at, a 16th of an inch tolerance would be my guess. I'll try and get a better answer for you, but I would say probably a 16th of an inch.
Perfect. I think we got time for one more, maybe. There's
Sure.
more that's coming in here. What is the average cost per square foot for synthetic slate roof?
For synthetic slate roof, I would say you're between $8 and $9, and that would include, this is just material. That would include your accessories as well as your materials.
Okay. That was a nice rapid fire round of questions. So thank you so
Good.
much. It is the end of the presentation now. I hope everyone has a great holiday and has a restful break. And thanks again, Jeff, for the presentation today.
Yeah, thank you.
All right, you guys, bye.
Happy holidays.